Hello, everybody, and welcome to the DI 101 webinar series. My name is Jared Evans, and I am the Director of Marketing for Distribution International. If you are new to the DI 101 webinar series, I can tell you that it is an incredible resource offered to DI customers, partners, and associates. By partnering with our manufacturers and our industry experts, these webinars deliver informative presentations about industry trends, new technology, new products, and product applications. In order to fully support our customers, Distribution International offers products and solutions from multiple manufacturers and brands in many product categories. This webinar does not represent an endorsement of one manufacturer or brand over another. We pride ourselves in partnering with manufacturers that deliver products of the highest quality to our customers. We are extremely excited to welcome our strategic manufacturing partner, DUNA USA, for today's webinar presentation. From DUNA, we have Chris Bullock, who has been in the industry since 1997. He's currently the head of technical sales for DUNA USA. He also has served on the Rock and Slag Steering Committee within NAIMA, and he has served on the ITAC 9 Department of Commerce. He is the current chairman of the F25.05 subcommittee on the proposed standard specification for selection and application of thermal insulation systems on liquefied natural gas, Type C tanks. We also from DUNA have Dave Francis. He's spent 4 years in technical sales with DUNA, but he's been in the industry for nearly 30 years. And so they are going to present a wide range of topics, but they're going to talk about PIR versus PUR and the differences in basic chemistry. They're going to talk about some liquids and adhesives, and go over pre-insulated pipe and advantages and limitations. We are proud to have DUNA USA present today, and we certainly thank them for their time. We will field questions at the end of the webinar. To submit questions, please use the questions tab on the GoToWebinar control panel. You can submit your questions at any point during the webinar, and we will answer the questions at the end of the webinar. So without further delay, I will turn this over to Chris Bullock with DUNA USA.
Thank you, Jared, and thank you, Distribution International, for allowing us a little bit of time to talk to you, your customer base, and the industry as a whole. We don't intend to go too detailed, and certainly are not going to get in one product versus the other, but just talk general conversation about PIRs and PURs and their application within mechanical insulation and some of the applications that they can be used for. We will go over a few guidelines that seem to be industry specific and recognized throughout the mechanical insulation world, and try not to bore you to tears in the process. So again, thank you for having Dave and myself, and we will get started. Kind of gone over where we're going to go. We want to talk about the foams products, PIR and PUR. We'll talk about the chemicals and the adhesives, and then go over where they've been used around the world. As you can see, that it's not just a specific location, but that this product base is known worldwide and something we're very proud of. Just a little bit of background on the company. We were started in 1957, and in '85 joint ventured with Dow Chemical. We are extremely known and knowledgeable in the foam industry. In 2001, we came to the United States in Baytown, Texas, where we've been ever since in the US. In 2007, we put a second building in. In 2010, we have a second location in Ludington, Michigan. We have a plant in the Fajua, United Arab Emirates. And so that gives us one in Italy, two in the United States, one in the Emirates. And so we do have worldwide capability. And our little map just shows that we like to think everywhere, and certainly in the major petrochemical parts of the world. And with the basics out of the way, get into what we're really here to talk about, and that's the rigid foams of our products. Most of you are familiar with the 2-pound polyisocyanurate foam blocks that you fabricate into pipe insulation. The main densities on that are 2, 2.5, and 3. We show 3.4 on the sheet, and we'll get to that in a little bit. One of the big questions, and certainly common ones right now, is the 2.5 pound foam has been specified on LNG plants. The 2.5 gets questioned on why that density, and it really started in Europe with the 50 kilogram per cubic foot is about a 3.2 pound density. It was a compromise in North America not to spend the money really on the 3 pound, and the 2.5 was close enough in performance. So that is why you see the 2.5 pound on big LNG plants being specified more and more and more. It was the closest to the 3 pound and kind of gave everybody a little bit of price break in the overall cost. And that is something that the industry has settled into. The foam itself is Class A under E84. This is a question we get asked a lot. Is the material 2550 rated? It is not. Most of the PIRs out there are not. There are a few exceptions, and the products that do meet it are quite good, even though the thickness levels is pretty thin and something that people should be aware of. But there are products that meet E84 2550. Currently, our products do not. We have a flame spread of about 20 and a smoke index anywhere from 135 to 185, depending on the test, but well below the 450 requirement for smoke to meet Class A. So it certainly is self-extinguishing, but again, we don't want to scream too loud, and it's certainly not a 2550 product. The closed cell content is above 95%. The PIR, polyisocyanurate standard, it really is about 92%. So we try to be well above that. And what that means is the cell structure, the gases inside the cell stay as an egg, so to speak, and do not break. The more unbroken eggs you have in the block that you get to fabricate, the better performing the product will be now, 6 months from now, 20 years from now. And so the higher the closed cell content is of a product, the better performing it is, and the better put together it is from a chemistry standpoint. And that is something that we are pretty proud of. Most of the PIRs in North America certainly are at the 95% range, and that just gives you an idea of the quality that the industry as a whole has, and some comfort that, you know, even if you don't use our product, you're certainly getting one that will meet your expectations and application needs, and it's something that you shouldn't have to worry about. One of the areas that DUNA takes very much pride in, and this starts in Italy and comes over to the United States, is our belief in green building and being as environmentally protective as we can. It used to be something that we talked about a little bit. It is a background that I have in from all the way back in school, and so something that's near and dear to me. But in today's administration, I believe you're going to see green building and the word green, leads, those sort of aspects more and more common. And ozone depletion potential, global warming potential are things certainly on commercial buildings that will be seen more and more. And so we just wanted to bring it up for you to be aware of, that our products certainly have excellent, excellent numbers. An ozone depletion level of 0 is as good as you can get, and a global warming potential of less than 10 is extremely low. For example, one of the main refrigerants, R22, has an ozone depletion level of 0.05, very low. It has a global warming potential of 1,810, and that's the best refrigerant on the market. So for us to have a 0 and less than 10 shows our commitment to what the EPA is going for in green building. What this means to you guys is not to bore you with this sort of thing, is as you look at green building requirements, you can have confidence that DUNA's product, the PIRs, will help with the overall number that carbon footprinting on a building may maintain or may require, and thus help you go after a job with a little more vigor, that you know that it will meet the environmental standards. We have lower installation costs and material costs for PIRs. That will be seen versus some of the other products. Certainly not what I would put as we talk about green building is the greener you get, typically the more requirements are required, and that's not always the most cost effective. At this point, Dave, you have anything to add?
Not at this point.
All right, we will continue on. As we get into some of the mechanical insulation guidelines, we get asked several times, at what point do you start double layering, triple layering? And our recommendations that are pretty industry common and recommended practices are on the cold insulations above 2 inches or below 2 inches would be a single layer, inch, inch and a half, up to 2. Between 2 inches and 5 inches would be a double layer application, and anything above 5 inches would become triple layer. Now the triple layer becomes important as you get up into above 5 inches of insulation, typically means the application is getting colder and colder and colder. You get to a point where the shrinkage compact of the insulation is greater than the steel itself. And that first layer can almost be sacrificial. It is going to shrink more than the steel. And so you need layers 2 and 3 to give the actual insulation value at the cryogenic level to make sure that the application stays within the required temperature. Between each layer, we recommend that you use a joint sealant, and there are several to choose from. We have the Foster's 9550 written down, but we do not tout them. We do not have a partnership, and so any of the joint sealers that are recommended would be perfectly fine. We like to show where you put it and to make sure that all the, at least the outer layer joints are butted together and sealed. And that's, will be partial important as we get into vapor barriers in just a second. On a triple layer design, as I stated, the inner layer a lot of times is sacrificial, and so there's no vapor barrier requirement there. It is going to shrink up and not go away. It will have some effect, but it is going to move on you. So the secondary vapor barrier is between the second and third layer, and the primary vapor barrier is on the outside before the metal clouding, jacketing, the actual protection of the assembly. Let me back up. I did leave one thing out that I would like to go over, and that's in the upper left corner. We do need to talk about staggering the joints, and it is something it's common and known, but we do want to stress that it's best to turn everything 90 degrees from one layer to another so that you have no chimney effect. Each joint is protected by the next layer, and then there should be overlaps as materials butt up against each other. So the idea is that nothing has a direct line from the piping to the surface, and you want to trap as much of the cold temperature as you can where it needs to be and keep the heat from the outside away. That was kind of the basics of mechanical insulation on piping. Rigid foam products are used in several different applications. The lower densities, the 2, 2.5, and 3 pound, everything from mechanical piping to the cold chain industry. And when we say cold chain, that's refrigerated trucks, panel systems, refrigerated buildings, doors. Anything that you're looking for with a high R value typically is a low density polyiso or polyurethane in an assembly to give it strength. And from there, you make a large cooler, so to speak. As we move up in the higher densities, anything from 8, 10, 15, 20, all the way up to 31 pounds per cubic foot. You get into pipe supports, thermal brakes, tooling applications. And then we have a Corinto line that is 700 and 800 kilograms per cubic foot, 63 pounds per cubic foot. That is more in specialty products and aerospace cooling, machining. You use it to make models of things that will be carbon fiber based. And so we don't deal with those in the mechanical insulation world a whole lot. But they are there, and they do have a little bit higher temperature rating. They get up into the 400-degree line. But I will say, before we go down and talk about them a whole lot, they have a board foot cost of $23 a board foot. So those high compression materials are certainly expensive and really extremely niched to specific industries. For the most part, the 31 pound and down will be used in thermal breaks, as the picture we show on the bottom left, to go between a concrete slab and the steel to keep it from being mitigation of temperature. Now, this is something that Dave's a little more familiar with, and let him speak on that a second.
All right. I don't see the slide yet, though, Chris.
All right. Well, I just have the same thermal break one up.
Oh, there we go. Pipe supports.
Yeah.
All right, so we can do this several different ways. You can do it with conventional foam, which is rigid foam that you cut into half sections like you see on the right. We also have liquid systems that pipe support manufacturers will have built molds from, and they will mold out curved segments as opposed to fabricating pieces out of rigid foam. It's 6 of one, half dozen of the other. Some of them seem to prefer the liquid systems, but we can supply both.
They are, common. There are big people out there that y'all certainly heard of. Piping Technology is a company that deals with the molded type of systems. We know several of your branches cut our blocks. And as Dave said, 610, one half the other, either one seems to work just fine. The idea, though, is that the larger diameter pipe supports need higher densities to handle the weight. And we certainly can support material up to 31 pounds, and all of the pipe support designs and sizes can be met with one of these two ways. It is certainly something well accepted within the industry. And if you were to get into the liquids, which we'll talk about in a little bit, we try to make the ratios easy to use, keep it dumb bunny simple, so to speak, and to make sure that we give as much support on that as we can. As we move from the blocks, which are the green supports, so they were either poured liquids and then into a mold, or cut from a block, you get into the liquids that were poured in place, and those are the pictures on the right. And again, Dave has more experience with this out in the field than I do, so I'll let him talk about this a second.
Okay, so what you see on the right is using an injectable liquid to create polyurethane foam around an item, whether it be a T-support, a flange pair, flange valve, whatever it may be. And if you go to the next slide, Chris, there's better pictures, more pictures, I should say.
Yep.
So the process is you're using liquid foam to insulate an item as an alternative to conventionally insulating it. And that's got a lot of features and advantages over conventional insulation. In new construction, if you have a high population of valves that need to be insulated and you choose the injection method over conventional, you're looking at a labor cost standing or differential 10, 15 times greater to do it conventionally than with foam injection. The process is simple. You determine what the thickness needs to be. You calculate the volume of the foam required using a configurator that we have, Excel-based configurator. You build the box, which is on the upper left. You fit it to the adjoining pipe. You inject foam, and then You walk away because you've then just insulated that item. And people often use the saying that something has to be better, faster, cheaper for somebody to change, but you can only get 2 of those 3. And the reality with this system is you get all 3 because it is faster, it is substantially cheaper, and I contend it's better. There's no seams, no gaps, no joints, there's no mastics, there's no glues. It's one big solid mass of foam. In the bottom left picture, or the one with the corner cut out, was done after injecting this as a sample test, removing the metal box to show everybody that there's no bubbles, gaps, voids. And then to further prove that, you cut off a corner and show that it's a solid 3-pound polyurethane foam, and you're done. We've had great success on the LNG projects in town, as well as the ethylene projects. And there's some ethylene and LNG coming up that we've had great success, and it's a great story to tell as a time and money saver. And if you go to the next slide, we actually show this in a little graphical presentation showing the different components, whether it be material costs, labor hours, and accessories.
I'll go to that slide in just a second. I did want to, since I'm probably scared everybody talking about the inner layer on large thicknesses being sacrificial, the upper right-hand picture shows where the valve is wrapped with a mineral wool blanket or a fiberglass, and that is kind of the cushion as the insulation will compress and shrink a little bit. That's factored into how you do these valves, and it is in our installation guidelines. So all that's factored in so that what you get is a picture like the bottom left that has no cracks, no voids. Even under operating conditions, it looks just like that. And I, not to cut Dave off, but want to make sure that we fully engineered these systems to do what they're supposed to at the cryogenic temperatures. There you go, Dave.
Yep, it compares conventional to a pour-in-place system called in situ foam. Material is going to be less. The installation man hours are a fraction, as are the joints in the system. Essentially, you have no joints with the foam system. And then the accessories, and there's another column you could put in there. It's harder to quantify, but from a material management standpoint, managing a roll of metal in some drums of liquids that turn into foam is a whole lot less than managing multiple pieces of fabricated insulation, bands, glue, tapes, mastics, fill in the blank. And the bottom line is, it's a better system. It's one big continuous piece of foam.
All right. Going along with the foam in place valves and flanges, sometimes you guys will hear about pre-insulated pipe. We have a product that's offered more in Europe than it is North America called spin pipe, but we're not the only ones that do it. Permapipe out of Nashville, Tennessee, certainly one of the big people that I'm sure everyone is familiar with, and they do pre-insulated pipe systems. Everything from fiberglass, mineral wool, to polyurethanes. Quite familiar with what they do, and the concept is the same, is that if you got 40-foot sticks of pre-insulated pipe, the labor savings is immense. But on each one of them, there's a cutback of 36 inches for welding. And so don't think because something is a pre-insulated pipe job that there won't be places that normal fabricated insulation will have to go. It will fill in all the gaps, the butt joints, the welds. And so you're not left out of those jobs at all. If it happened to be pre-insulated from some other system. The quality of the product, we got nothing to say about it. We don't do it here, but those systems are quite efficient and quite popular in places with 30-year thermal loss protection. But just don't think that you're out of the game. That those jobs are something to look at. There will still be a good bit of mechanical fabricated pieces and insulation that go to them. With all of the polyurethanes and polyisocyanurates, places that require adhesives, we recommend that you use a polyurethane-based adhesive. Don't just use Elmer's glue, so to speak. You want an adhesive designed to put material to material together and also can handle the temperature range of negative 328 degrees. So you don't want your adhesive to crack, bust, or fail, and thus give you the ability for the system to fail. And system failure is a big thing that people talk about these days. We get asked about warranties from time to time on the product. We're hesitant to talk warranties because the warranty is more involved with the entire installation, not just the material itself. Very, very, very rarely is there going to be a problem with a fully cured, properly fabricated piece of pipe insulation on polyiso polyurethane. It just doesn't have a problem. However, if the installation is not put together right, the joints aren't sealed, they're not staggered, and you have place for moisture to mitigate one way or another, that's where you end up with problems. Most of the warranty issues, 90% of them or more, have to do with the installation and not the material itself. And so that's something that we stress, is that make sure that the people putting them together follow the rules and follow the recommendations, and from that standpoint you have a much better fighting chance. We do offer adhesives, not a big mover for us. There's several out there, and again, our biggest recommendation is get a urethane based adhesive for urethane based installations and insulations. As we started earlier and showed you how DUNA's got a footprint worldwide, we put these projects up just to show that PIRs, PURs are known worldwide as well. This is not a North American product that's only done here. This is a product known everywhere, from the US to Russia to Qatar, Algeria, Australia, Malaysia. This is an extremely accepted and approved product, and so should have no problem recommending it in jobs in the United States and knowing that it has the backing worldwide. Would you like to talk about some of the Gulf ones, Dave?
Yeah, I mean, the list has actually grown since then. And what I've told people is DUNA is a worldwide recognized name and often shows up in, I'll call it foreign companies, Toyo Engineering or Chiyoda. To them, it's been a go-to for decades. And as those companies do more and more work in the US, those called the quote unquote European spec or the DUNA Cordini European specs will show up in US specs. And it's a well-known brand name globally.
Thank you. Excellent. And that brings us to the end of the basics. And we do thank you for letting us show out and showcase what we do and what we recommend. And thank you for attending. And I'll turn it back over to Jared at this time.
Thanks, Chris. Really appreciate it. Thank you guys for taking time today. We'll give some questions, a couple minutes for questions to come in. And while we're waiting for questions, I do want to just take a second to tell everyone about our digital customer platform. Last year, we completely overhauled our website, distributioninternational.com, and we added a wide range of value-added features, including our customer portal called Customer Connect. You can view past invoices, request quotes, and even submit orders online. Maybe the best feature is a detailed online product category of more than 29,000 products. It's easy to search, easy to navigate. Go to distributioninternational.com today and register for your online account and see how it'll make your job easier. Also want to remind everybody to follow us on LinkedIn and YouTube. On YouTube, we do post recorded webinars, so you can go back and look at that as a reference. And on LinkedIn, it's the best way to stay in tune with upcoming webinars that we do. We do have one question, and And part of this question is about pricing. So I will just say in general about pricing, if you would contact your local DI or Crossroads, if you're in Canada, Crossroads branch or representative. The pricing does vary depending on where you are. So reach out to your DI branch and or Crossroads branch, and they will be happy to work with you and get you some get you a quote. The other question on here is how do you decide if we need to inject liquid PIR, PUR, or rigid foam for pipe support?
How do you know when you should?
Yeah, how do you decide if we need to inject versus doing the regular rigid foam?
Oh, that's that will typically come from your pipe support manufacturer. He may have a preference. He may have molds in place that he already has for pouring the support, or he may elect to cut it out of existing rigid foam, or he may have the ability to do both depending on the size. Obviously, with a block of foam, you can cut any size you want. If you've invested money in molds to pour those things, I don't think you have, I'll say, an unlimited number of pipe sizes and installation thicknesses. I think that from a cost standpoint, the liquid system is going to be less expensive than cutting it out of rigid foam. So I think it comes down to commercially, what's easiest and best to fabricate from, either liquids or solid foam. I don't think there's a black and white technical reason.
I agree with that. Not a complete black and white technical. Sometimes the specifying engineer will say no joints or seams in the pipe support though. And if there is that, and it's say a 36-inch diameter pipe, you're almost having to go with a liquid poured set into a mold so that you don't build up a block and cut it and have glued sections. That comes from the engineers, not really from us. We've seen it done both ways, but again, that really comes from elsewhere.
Great, and I do want to just remind all of our customers that are on the webinar that Distribution International does have some fantastic fabrication facilities throughout the country that fabricate the rigid foam, but we can also even fabricate the metal boxes for the injected liquid foam as well. So be sure you reach out to your DI representative if you need more information about our fabrication capabilities. That's all the questions that have come through. We did have a couple of people that posted thank you and well presented. So hats off to you, Chris, and both of you guys for a great presentation. We really appreciate you taking time to help provide this value-added service to our DI customers. Again, want to wish everybody a happy upcoming 4th of July holiday, and hope everybody stays safe, and keep an eye out on LinkedIn and through your emails for the next upcoming webinar. Thanks, everybody, and have a wonderful afternoon.